that the temperature doesn't vary much between the daily maximums and the daily minimum. This is historic for that period, and you will see that there is less than 10 degrees, so this is not substantial. The average rainfall in millimeters in this year, in the month of the years, is also of interest, because we can see very clear, if we look at the precipitation in the year, and we look at the number of days, average number of days in these particular months through the year, we can clearly see that the rainfall in Cuba is modulated by two major drivers. One of them is the hurricane related variability, and you can see that the majority of the days and the higher precipitations are between the months of June to September, October, and that's the hurricane season. And the other important data that we can see from here is that the precipitation is also modulated by the cold fronts that are driven from the north towards the south in the winter northern hemisphere. Those two elements are drivers of precipitation in Cuba. In terms of where do we store this precipitation of the water, there are about 40 million existing 50 million cubic meters stored in existing today reservoirs, and these are reservoirs of surface water. Cuba, to the best of my knowledge, doesn't have subsurface reservoirs, artificial. We're talking about artificial man-made reservoirs. This map depicts the location of the existing reservoirs, and we can see that there is a concentration of them, of course, in the area close to the city of La Habana, and then it's more or less evenly distributed through the rest of the island. Where are the major reservoirs with more than 100 hectare cubic meters? Of course, again, the distribution is quite homogeneous throughout the island, and these are, as you can see, there are approximately 20 reservoirs of what they call high capacity surface reservoirs, man-made, where water is stored. Let's talk about water quality. It was mentioned very at the beginning by a few of the colleagues, the concept of water quality in Cuba. Well, in terms of drinking water infrastructure, there are about 240 of those reservoirs that I just showed that are basically for drinking water. There are about 805 micro dams or small dams that have been constructed to maintain water for drinking. There are 6 large pumping stations and about 2,400 or so aqueducts, which more than 22,000 of kilometers of pipeline. Now, this is the infrastructure that is provided as information by the government of Cuba. However, what is the state of this infrastructure is something that I'm sure my colleagues later in the will discuss. But to give you an idea of chlorination in Cuba, this map shows two things. One is the chlorination density, and the color green goes from lighter green to darker green, and the darker green corresponds to approximately 300 stations. So you can see where the majority of the stations are located in the, I will say, eastern part of the island, of course close to the city of La Habana, and then you see also a higher concentration of chlorination stations in this tip. In general, the central part is the area with less chlorination stations. On the other hand, the pink dots represent water treatment plants and the location of these water treatment plants. And so they go from 0 to 10 liters per second, which are the tiny small dots that you probably can't see. And then it goes from 10 to 100 liters per second, and then over 500 liters per second, the bigger dots, which are usually concentrated close to major urban developments. This is what is presently in the country. Now, despite this infrastructure and the span of the chlorination stations and treatment plants, still the situation is that according to information provided by the Institute of National Resources, and this was this number here comes from a quote of the director of the Institute in 2012, around 6% of the Cuban must still get their water either from cistern truck or other means. These are private developments of that people have in their houses to sell water. Yes, so the people that are coming to obtain their water from the tanks or from these water shops, I will call, are people that either do not have access to clean water in their homes or do not have permanent access of water to their home. Now you have to be aware that a high percentage, in some cases over 60% of the water resources in the pipelines are lost, basically. And also a number of the water supply pipelines are deteriorated and are extremely contaminated. So the water may reach you, but it will not be of a quality that you can drink. So therefore, a number of people in the population still have are required to have their water in this way. Now, I've talked and I mentioned the Institute for the National Institute for Hydrological Resources or Water Resources. This is the institution, the official institution in Cuba that is responsible for monitoring and providing information on water resources. It was first founded in 1962. It went through a major restructuring and it was reopened or reinstituted in 1999. What are the services that this entity provides? Basically, they provide information on daily rainfall on a permanent basis. They also have online and publish the monthly hydrological bulletins, which give information on rainfall, water levels in the reservoirs, and groundwater levels. They also carry out study and hydrological assessments, as well as the Institute is responsible for gathering information, data, and carrying out analysis. The information is gathered, of course, from the hydromet station. They also are in charge of predicting and participating in the joint multi-institutional task force of extreme events, particularly droughts, floods, and they are responsible for the early warning system in watersheds. Now, keep in mind that not all watersheds have an early warning system. In terms of the equipment that they have available, and again, I cannot vouch for how much of this equipment is really working, but they have about more than 2,000 pluviometers throughout the country, about 55 pluviograph, 13 climate station, which is really very small number, 38 hydromet station, 1,700 around hydrologic station, and then more than 2,000 water quality stations. This is one of the products that they have available, and this is what they called the drought service that they provide at the beginning of the dry season, usually in January. I haven't seen the one for this year, but this was the estimate prediction of drought in Cuba for the year 2013. And the dark brown areas indicate a high probability of drought, while the green areas indicate a high probability of higher than normal precipitation. That doesn't mean necessarily floods. And then finally, we have the water footprint, which gives us the amount of volume of water that is used to produce goods in Cuba, and as consumed by inhabitants of the nation. So in other words, to produce whatever you produce, you have to use water, and then so to produce coffee, sugar, bicycles, whatever. It's interesting to note here that Cuba is basically the fifth after France, and it's very high up there with first world countries. Now, this doesn't necessarily tell you that the use of water resources is at the first developed country level. It could indicate also that there is a lot of loss of water resources, and that is why they are in that, Cuba is in this position. But this is interesting because the main water markets are guided by the water footprint. And just to let you know, the distribution of the majority is agriculture, and the majority of the water use is in agriculture, followed by industrial, and followed by municipal, and finally industrial. And this is, like I said, an average approximately calculated between the year 208 and 212. And so, thank you very much, and we're willing to take questions later. Thank you.
Thank you very much, Dr. Donoso, for that very thorough presentation that sets the stage for our discussions this morning. Next, we're going to have Mr. Cueto.
Good morning. Today I'm going to be giving you guys a presentation basically outlining an evaluation on Cuba's water and wastewater infrastructure that was conducted as part of a study which was sponsored by the Cuban American Association of Civil Engineers and the Association of Cuban Engineers. This study was published by myself and a colleague of mine, Omar de Leon, and it has been published in the annual proceedings of the Association for the Study of the Cuban Economy in Washington, D.C. If you bear with me a second, I'm going to pull up the PowerPoint. Okay. As I mentioned, this short presentation looks to provide a baseline evaluation of Cuba's current water and wastewater infrastructure, and then we'll go forward a little bit and elaborate on possible improvements in the future and some order of magnitude costs. Specifically, we'll be focusing on the comparison currently between demand versus capacity to determine if Cuba's current water and wastewater infrastructure meets the needs of its current population. This presentation, I'd like to note, also builds a lot on Dr. Donoso's presentation, as a lot of the data is taken from the same institute that she mentioned. In Cuba, like in any other place in the world, there's two primary sources of water: surface water and groundwater. In the case of Cuba, surface water accounts for about 65% of the available water supply. As Dr. Donoso mentioned, there are 8 priority watersheds throughout the country, geographically distributed about evenly. These 8 priority watersheds provide 40% of water to about 40% of Cuba's population. On the other hand, groundwater accounts for about 35% of Cuba's available water supply, But interestingly, groundwater is predominantly used in urban areas, most notably in La Habana. This is a map illustrating the location of the 8 priority watersheds. Most of them are located, as can be logically deduced, in where major rivers exist, such as El Río Toa and El Río Cauto in the western portion of Cuba. In all, there are about 59 surface water treatment plants in Cuba. We know that many of these surface water treatment plants experience a number of operational issues. There's a shortage of chemicals in many of them that do not allow for adequate water treatment processes to go forward. There's generally poor equipment reliability in the sense that pumping units many times do not work and don't allow for water to get from a reservoir to the plant or through the plant. And many times things such as instrumentation do not work, and tank levels and other operational parameters cannot be met to meet water quality downstream at the end of the water treatment plant. Also, quantity and quality of filter media is an issue, many times allowing for pathogens to travel through the water treatment plant without being captured and end up in the faucet of many everyday Cubans. On the other hand, there are about 2,000 groundwater chlorination stations on the island. Essentially, these are pumping units which receive a dose of chlorine and are disinfected before being pumped into the distribution system and consumed by the Cuban population. The primary issue with the existing infrastructure in this sense in Cuba is that there's a lack of chlorine gas. Chlorine gas is the agent used to disinfect the groundwater, and many times, unfortunately, due to the state of infrastructure in terms of transportation or just availability of funding, there's not always an adequate supply of chlorine gas to disinfect the groundwater that is consumed by the Cuban population. This was one of the graphics that I think was included in the last presentation and created in our paper, which shows the location of the 59 surface water treatment plants throughout the island.